Introduction to ocean tides. Ocean tides are the regular rise and fall of sea levels caused by the gravitational forces exerted by celestial bodies. The primary driver of tides on Earth is the Moon, with the Sun also playing a significant role. Understanding the causes of ocean tides and their relationship to the Moon helps explain various coastal phenomena and their impacts on marine and human activities. The role of the Moon. The Moon's gravitational pull is the main force responsible for ocean tides. As the Moon orbits Earth, its gravity pulls on the Earth's oceans, creating a bulge of water on the side of Earth closest to the Moon. This bulge is known as the high tide. Simultaneously, on the opposite side of Earth, another high tide occurs due to the centrifugal force generated by the Earth-Moon system's rotation. The areas between these two bulges experience low tides. The Sun's influence. While the Moon has the greatest influence on tides, the Sun also affects them. The Sun's gravity pulls on Earth's oceans, but its effect is less pronounced compared to the Moon because it is much farther away. The interaction between the Moon and the Sun's gravitational forces can either amplify or diminish tidal ranges, leading to different types of tides. Spring and neap tides. Tides vary in intensity, resulting in spring and neap tides. Spring tides occur when the Moon and Sun are aligned with Earth, either during a new moon or a full moon. This alignment causes their gravitational forces to combine, resulting in higher high tides and lower low tides. Neap tides occur when the Moon is at a right angle to the line between the Earth and Sun, leading to lower high tides and higher low tides due to the partial cancellation of gravitational forces. Tidal cycles. Ocean tides follow a predictable cycle influenced by the Moon's position relative to Earth. Typically, most coastal areas experience 2 high tides and 2 low tides in a 24-hour period, known as a semi-diurnal tide cycle. Some places may experience only 1 high and 1 low tide each day, called a diurnal tide cycle. The exact timing and height of tides are influenced by the geographic location, local topography, and the positions of the Moon and Sun. Tidal currents. In addition to changes in sea level, tides generate tidal currents, horizontal movements of water caused by the rising and falling of tides. These currents can be strong and influence coastal navigation, sediment transport, and marine ecosystems. Tidal currents are especially pronounced in narrow estuaries and straits. Tides and marine life. Tides have a significant impact on marine ecosystems. Many marine organisms have adapted to the regular tidal cycle, using it for feeding, reproduction, and migration. For example, intertidal zones, the areas exposed during low tide and submerged during high tide, are home to a diverse range of species that must withstand the challenges of fluctuating water levels. Human activities and tides. Understanding tides is crucial for various human activities. Coastal engineering projects, such as the construction of docks, harbors, and flood defenses, must consider tidal patterns to ensure functionality and safety. Additionally, tides affect fishing practices, with some species being more accessible during specific tidal conditions. Tides and climate change. Climate change can influence tidal patterns and their impacts. Rising sea levels, caused by global warming and melting ice caps, can exacerbate tidal flooding and affect coastal ecosystems. Changes in ocean temperatures and currents can also alter tidal behaviors and marine life. Conclusion. The interplay between Moon and tides. Ocean tides are a direct result of the gravitational forces exerted by the Moon, with the Sun also contributing to their variations. The regular rise and fall of tides play a crucial role in shaping coastal environments, influencing marine life, and affecting human activities. Understanding the dynamics of tides helps in managing coastal areas, protecting ecosystems, and anticipating the impacts of climate change.